Hi guys. So last time we saw the digit extraction algorithm, and today we're going to solve a LeetCode problem related to that algorithm, which is called reverse integer. Okay. So let's see the problem. So we are given a signed 32-bit integer x, and we need to return x with its digits reversed. And if reversing x causes the value to go outside the assigned 32-bit integer range, which is this range, then we have to return 0. And we need to assume that the environment does not allow us to store 64-bit integers. Okay, so before understanding all of this, let me quickly explain you how integers are stored inside the memory. Okay, so in the memory, let's say you have a 4-bit integer. Okay, a 4-bit signed integer. Now, what does signed mean? Signed means that it can store positive as well as negative integers. Okay, so if you have a 4-bit signed integer, then your 1, 2, 3, 4, 4 bits will be reserved in the memory to represent the actual value of the integer. This first bit is usually called the sign bit. So which if it is 0, then the number is positive, and if it is 1, then the number is negative. Okay, so in positive means 0 and negative means 1. The rest of these 3 bits represent the actual magnitude of your integer. Okay, actual value of your integer. So so if you want to say, okay, what is the maximum value that can be represented using 4 bits, then the maximum value would always be positive, right? So maximum value would always be positive. So this sign bit will be 0, and rest of these bits will be equal to 1. Since we need the maximum value, so all the bits need to be equal to 1. So how actually you calculate the integer value from this is 2 to the power 0 into 1 plus 2 to the power 1 into 1. This 1 is actually multiplied by the place of the bit. So this is 0th bit, this is first bit, this is second bit, and this is the third bit. Okay, so 2 to the power 0, 2 to the power 0 into this bit, which is 1, then 2 to the power 1 into 1 plus 2 to the power 2 into 1. Okay, so this will be equal to 4 plus 2 plus 1, which is equal to 7. Okay, which is actually equal to 2 to the power 3 minus 1. So as a general rule, if your n bits are being used to represent some integer, then your maximum value would be equal to 2 to the power n minus 1. 2 to the power n minus 1. Okay, so let's say now you want to see, okay, what is the minimum value of an integer that can be represented with these 4 bits. So your minimum value would always be negative, right? So this sign bit would be 1, and since our value must be minimum, so each of these bits will be equal to 0. Now this actually represents minus 8. This is the 2's complement. This is the 2's complement of minus 8. Now what is 2's complement? If I explain this, the video will be very long, so I encourage you guys to Google out this stuff and learn this on your own. So as a rule of thumb, we say uh, if n bits are being used to represent an integer, then the maximum value is 2 to the power n minus 1, and the minimum value is equal to minus 2 to the power n. Minus 8 in this case is minus 2 to the power 3, since here these 3 bits are being used to represent the magnitude of the integer. Remember, these n bits represent the magnitude of the integer, not the actual integer. Okay. So yeah, as a rule of thumb, you should always uh, remember this. So yeah, now let's see how you would actually approach this problem. So I have taken an example of x equal to 1, 2, 3, 4, 7, 6. So in the normal digit extraction algorithm, what we used to do is we would do modulo of this with 10, which would give you 6. And then we would divide 1, 2, 3, 4, 7, 6. We would perform an integer division of this by 10, which would be equal to 1, 2, 3, 4, 7. Now, in this digit extraction algorithm, your digits will be extracted in reverse order. So first you'll get this 6, then you'll get this 7, then you'll get this 4, then you'll get this 3, then this 2 and 1. Okay. So now, since you need to store these digits somewhere in the order that we are getting it, in the same order that we are getting it, let's say we take a new integer called n, which is equal to 0, and as we get our as we get our digit, we would somehow be storing it in that order inside this n variable. Okay, let's see how we will do that. So after this operation, your x would be equal to 1, 2, 3, 4, 7. Now again we would do modulo 10, which would be which would give us 7, and we would do 1, 2, 3, 4, 7 integer division by 10, which would give us 1, 2, 3, 4. Okay. Now at first, our let's say this was stored inside a variable called digit. So at first our digit was equal to 6. Now our after this operation, in the next iteration of the while loop, our digit variable is equal to 7. Okay, our digit variable is equal to 7 now. So let's say if as you get this digit, you add it inside n. So let's say n equal to n plus digit. What would happen if you do this? So first your n was 0. Now in 0, if you add 6, you would get 6. And when you get 7, if you add 7 inside 6, then you would get 13. But since we need to store the digits in the reverse order and not actually change the number, somehow we need to have, if your n is equal to 6, if your n is equal to 6, then we want 67. We want 67. We don't want 13. We want 67. So how would you do that? So let's say if you multiply 6 by 10 and then add 7, you would get 67. So instead of this here, instead of n plus digit here, we can say n into 10 plus digit. So now every time you get a new digit variable, every time it's stored inside n, it's stored at the units place. It's not actually added to the uh, number. It's this digit is actually stored at the units place. So now let's say after this iteration, our x would be equal to 1, 2, 3, 4. Now again, if you do modulo 10, you would get 4. Your digit will be equal to 4. At this point, our n is equal to um, 67. As you get this 4, this 67 will be multiplied by 10 and 4 will be added, which would give us 674. 674. Then again you would do 1, 2, 3, 4 integer division by 10, which would give you 1, 2, 3. And then again you would do x equal to 1, 2, 3 modulo by 10, which would give you 3. Your 3 will be added here. Then your 1, 2, 3 integer division by 10 give you 12. Now again x equals to 12 modulo 10, 2, this 2 will be added here, and this would integer division would give you 1, and our x would be equal to 1 modulo 10, which will give you 1 again. This 1 would be added here, and your 1 modulo 10, sorry, integer division 10 would give you 0. Fine, and the algorithm will stop. So your 1, 2, 3, 4, 7, 6 got converted to 6, 4, 3, 2, 1. So this n equals to n into 10 plus digit is the new modification that we have to include in our original digit extraction algorithm. Now let's go to the code editor and actually write the code for this problem and see uh, what cases we have to handle next. Okay, so let's say our new reversed integer would be stored inside this int res, which would be equal to 0, and while our integer x is greater than 0, our integer x is greater than 0, we need to say int digit equals to x modulo 10, and res equals to res into 10 plus digit. Okay, and x would be equal to x integer division by 10. This in Java actually performs an integer division. Since our x is an integer, this automatically, the result of this would automatically be converted to integer and stored inside x. Now there is a problem with this. What is the problem with this? If you actually now just let's say return res, if you actually run this code, it gives you wrong answer for a negative integer. Okay, we forgot to handle the case of negative integers. Now also we need to take care of this small note that they have given. We have to assume that the environment does not allow you to store 64-bit integers. Now in Java, your 32-bit integers are represented as int, and your 64-bit integers are represented as long. Okay, so what this means is we are not allowed to use long in our code. We can only use int in our code. So this is a little tricky, and let's see how we would use that fact. So now in order to handle these negative cases, our algorithm would actually fail in the case of a negative integer. Let's see how. So let's say your x is equal to minus 1, 2, 3. Now if you do minus 1, 2, 3 modulo 10, then you would get 7. Now this is not expected as you want 3, but you would get 7 in this case. So now let's see how you would handle this case. Our x is negative. If our x is less than 0, then we would introduce a flag, a boolean is negative, which would be initially equal to false. Now if our integer x is positive, then this is negative flag will be false, and if our integer is negative, then we would say is negative is equal to true, and if your number is minus 1, 2, 3, then we would discard this minus right here. If your number is minus 1, 2, 3, then we would convert it to 1, 2, 3. So in Java, we would say x equal to math dot absolute of x. So this function would only take the magnitude of x and discard the sign out of the integer x. Now this algorithm would perfectly run. Now this algorithm would perfectly run. Just while returning, we have to take care if our is negative flag is true, which means our original number was negative. So its reversed integer would also be negative. So in this case, we would return minus res, okay, or else we would return res. Now let's run this code and check. Our test case for negative integers is passing now, but but here we are missing an edge case. So now let's see what is the edge case that we were missing before. So for example, since our original question says that our x can be in this range, so let's assume that the x given is equal to this 2 to the power 31 minus 1. Now 2 to the power 31 minus 1 is also the maximum value that can be stored inside of int in Java, inside of an int variable in Java, okay, in Java. So let's say your x is equal to this particular value. So now if you want the reversed digits for this, what would happen is, so our x would be equal to 2, 1, 4, 7, 4, 8, 3, 6, 4, 7. And first we will take the modulo 10, which would give us 7. Initially our res would be equal to 0. Then when we do 2, 1, 4, 7, 4, 8, 3, 6, 4, 7, integer division by 10, would get 2, 1, 4, 7, 4, 8, 8, 3, 6, 4. Okay, so this 0 will become 7, and similarly, so first you'll get 7, then you'll get 4, then you'll get 6, then 3, then 8, then 4, then 7, then 4 again, then 1, and after this you should get 2 here. You should get 2 here. But if you see this number 746384741, this number right here is actually this is greater than this value. This is greater than. So our this res variable is an integer in Java. As you can see here, our res is int in Java. Okay, so our program would actually not behave as expected. If you try to store a value which is greater than the maximum value which can be stored inside an integer in Java, then that may not behave properly. So let's try and run our algorithm. So now let's try to run our existing code on x equals to 2 to the power 31 minus 1. This is actually 2 to the power 31 minus 1. So as you can see, our program is not behaving as expected, because if your value goes outside the range of the maximum allowed integer, then Java, I think, what it does is it if it overflows, it starts with a negative value. So Now, how do we fix this? How do we fix this? In this case, what we can do is, as you are inserting your digits inside this variable res, so first 7, then 4, then 6, then 3, then 8, then 4, then 7, then 4, then 1, and then when you are about to insert this 2, when you're about to insert this 2, if 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 your value, if you insert this 2 and your value goes outside of this maximum value, then you would return 0. Then you would return 0. Now let's see how we can do this in code. So here we would say that if your res into 10 plus digit goes greater than your integer's maximum value, then we need to return 0. Okay, then we need to return 0. Now let's also try and run this code and see what happens. So as you can see, we are still not passing this test case. So what is the problem here? What is the problem here? The problem here that is that when you compare this value with this value here, our when you compare our when you say res into 10 plus digit is greater than your integer's maximum value, which is 2 to the power 31 minus 1. uh, this value actually this value is equal to this particular number here. This would evaluate to this 746384741 2. This would evaluate to this number, and this is already representing the maximum value of the integer. So now this is overflowing. This is overflowing. Again, this expression which evaluates to this value is overflowing our range. So this would again evaluate to some negative number in Java, and this would not produce expected results. So instead of writing it like this, what we can do is res if res is greater than 2 to the power 31 minus 1 minus digit and this whole thing divided by 10. This whole thing divided by 10. Now what would happen is this res would never go to this res would stay like this. This trailing 2 will never be added here, and it will never overflow the maximum integer value. And this part would also, since this 2 to the power 31, this whole expression is actually less than the maximum value of the integer which is allowed. This is also inside the int range, and this is also inside the int range. And now this would be valid, and our test case would pass if we do like this. Okay, so instead of this, we can write integer dot max value digit minus digit, and we would divide this whole thing by 10. Okay, now let's run this code. Okay, now as you can see, we are successfully returning 0. So before submitting the code, let's evaluate the time and space complexity first. So since the base algorithm is same as the digit extraction algorithm, we saw that the time complexity, the time complexity for the digit extraction algorithm was O of log base 10 of x. X is the input here, okay? And here, as you can see, uh, we are using three variables as extra space. One, this boolean, then this integer res, and this integer digit. So whenever you declare an integer, it takes up some amount of space which remains constant. Okay, so no matter how big this x is, the space occupied by these three variables would remain the same. So the space complexity for this, the space complexity would be O of 1. Okay, now let's submit our code and see. So as you can see, our code is actually accepted. And yeah, so that's how you solve this LeetCode problem called reverse integer. And thank you guys for watching, and see you guys in the next video.